Hello, I'm Professor John Vandalen, co-director of the Center for Risk-Based Community Resilience Planning, headquartered at Colorado State University. This is a demo of the in-core app for the Joplin Tornado. So first we sign in with our credentials, and what you can see here, I'll pause it a little bit, but what you can see here is the Community Resilience Planning Guide developed by the National Institute of Standards and Technology, and that's been linked with the in-core engine. So in-core is running on the servers at NCSA with the user's data, and the data is secure. And so the first step of that guide is to identify a resilience leader, and this could just be for any project. And then that second step is to characterize the community's social dimensions. So this can come from census data, looking at demographics and vulnerable populations, as well as economic data. And then we see here the different building clusters. So this is critical acute care hospitals, and these clusters align with those in the guide. And now we get into what in-core can do, and that's here we see the building inventory, and we can see the electric power facility. So this is for the city of Joplin, Missouri, and then interdependencies between buildings and power. And in this case, it's the poles and the substations. And so here you can see we bring in all the substation information, all the shape files and other info that gets imported. And the electrical power, later we'll run this and show how this works, but and then we can define the hazard itself. So in this case, it's a tornado, but it could be a windstorm, an earthquake, can be anything that we choose once the app's developed for that. And it allows us to create our, say, in this case, it's an enhanced Fujita 4, level 4 tornado. And so we click, and then we click again and hit save, and this will generate a tornado. And the shape of this hypothetical or idealized tornado comes from about 44,000 tornado records over a period of 40-something years. And you can also decide that you want to put in a wind field. So this is showing another one. We can also put in the Joplin tornado itself. And so this is how we would essentially import a raster for a wind. It could be a Santa Ana wind. It could be whatever wind field that we want to import, and that comes in as a raster from the climate experts. So this is the interface to create this tornado hazard, but again, it will work for any hazard eventually. And then the idea is to determine the anticipated performance. So what's the damage and the behavior, the functionality of these systems. And so here we can see we're looking at, in this case, I'm showing the old semi-annual meeting demo from our center. And we have poles, and then we have the substations in Joplin. And so we'll put both these in. And we're going to click and have those have that one-way dependency. So the buildings are dependent on having electrical power for their functionality. And you can choose to turn that off too and just look at the damage. And then if you need to add data, you would click here. And you can continue to upload data, and there's a certain format. And so we're going to submit this to run. And you can see on the right, it's running when it's finished, and it'll tell you when it's done. It's just takes a little time. It depends on the size. We obviously the data sets can become aggregated and things like that, and that's part of the user process for those that are versed in using this. Then we see the interdependent network for the buildings and the electrical power. So here's Joplin. These are all the buildings. The color is different. The color here, these are substations. And then the color is actually the coverage area for the buildings in Joplin. These are not poles. These are actually the buildings. And we can view building damage as well. So we'll take a look at that. And here, this shows the building damage. And as you expect, it's similar to the tornado path, of course, but it puts it in terms of critical facilities, emergency housing, community recovery. And these are the four playbook or community resilience planning guide categories. But this of course, is variable. And so when we can see insignificant damage, moderate, extensive, and complete damage, and then how many buildings are in each of those categories. And so this is essentially a form of a dashboard. And we have a few different formats for this. And just an example of the GUI. And then we'll take a look at electric power facility. This is pole damage. So this is, in this case, we're modeling every pole in Joplin for this square or rectangular area. Here we can see, obviously, the damage again is very similar to the shape of the tornado for obvious reasons. For a large wind area, it could be scattered quite a bit, especially in a tornado, the winds are very high. So the poles tend to be damaged just like trees snap. And here's our substations, and you can see we have two substations in red in the center. Those were failed, and then one that was more yellowish orange, and that means it has a high probability of being failed or failure. So here's our building functionality, and this is with interdependency or one-way dependency really on the electric power system. And you can see, you can hover your mouse over here and see exactly what that level is, or you can just read it off the y-axis. And then our dashboard for the buildings down below. And so zooming in here for a second. And here we start to see how the resolution, we can see each building. And so this is really one of the nice features is that then we have this dashboard with looking at the four areas. And of course, this could be changed depending on a user's needs. And then the percent of functional and non-functional. And then this shows the actual number of buildings in each of those categories. So medical, healthcare, could be a hospital, but it's really the buildings within a hospital. Often they're made up of many buildings as well as other types of critical facilities. And then you have manufacturing and the community recovery, things like that. And now we can look at the building functionality without that interdependency. And that might be something that's important just to see, which ones are non-functional due to damage, and that functionality has a certain definition. Of course, that definition can be changed. In this case, it's a 50% probability of exceeding a damage state 2, level 2, and that's out of 4 levels. And so here we see these values, and of course we'd expect them to here you can see we'd expect so 53% is functional, 46% non-functional, and we'd expect this to have more functional because of course the electric power is out. So if you do that one-way dependency for the buildings on electrical power, then generally it'll be much higher. And then we can download the tables, download the data, that'll bring everything in. And so, really and so this would give us our anticipated performance. Another thing that is not in the app, but that we're working on is bringing in the population dislocation, and that can be demoed, and you'll see that in some of the other videos on the YouTube channel. And those involve population dislocation using algorithms that are based on damage as well as the demographics from the US Census, and it uses a synthetic population allocation algorithm to get populations, to get families into houses and households, and then also the ability to compute the effects on the economy. And so I'll stop there. And please visit the YouTube channel for more videos.